Hello, Math 1680 students. Here is Lesson 3, Bivariate Data. This topic corresponds to Chapter 4 of our main textbook by Sullivan and Chapter 3 of our auxiliary textbook by Johnson and Kuby. Alright, let's begin. Section 1, Types of Bivariate Data. What exactly do you mean by bivariate data? What is it? Bi means two, variate means changing, varying, so we are talking about two variables. But of course, this is a math course, so not any two variables. There gotta be some rules, some mathematical rule. Here's the rule. The values of two variables that are obtained from the same elements of the population. This is the key. Same elements of the population. Now, depending upon the types of variables, we may consider two qualitative variables, one qualitative and one quantitative variables, or two quantitative variables. But in any case, those two variables must come from same element of the population. Let me show you. Here's a concrete example. An example of two qualitative variables. Let's consider a hypothetical group of 30 college students. We have those names. Names themselves are not important, but they point to a single student. And what is the rule? Going back to same elements. So that's what these names are doing. Names themselves don't really do anything, but they can actually identify to one unique person. Now we have two variables here, two qualitative variables here, gender and major. For gender, we have male or female. Major, well, in real university, there must be some large number of majors, but this is a classroom example, just a hypothetical group of 30 college students. So let's keep it simple. Let's just consider three majors: liberal art, business and administration, and technology. So we have two categorical or two nominal variables here. Now, how do we present this? Here's a good descriptive statistics of a bivariate data associated to two qualitative variables. A contingency table, or alternatively called cross-tabulation. Personally, I prefer the term contingency table, but I'm going to use this second term, cross-tabulation, a lot too, because our textbook author mixed-used both of them, and of course, the purpose is to make everybody familiar with both of these terms. Okay, here's the structure. We have two variables, gender, and they go to rows, and major, they go to columns. So we have first row for male, second row for female, and three columns for liberal art, business, and technology majors. Now we have 5 male liberal art majors, 6 male business majors, and 7 male technology majors. They add up to 18 men. Likewise, we have 6 female liberal art majors, 4 female business majors, and 2 female technology majors, adding up to 12. And then 18 plus 12, we have total 30. See the structure? How about the majors? 5 male liberal art majors, 6 female liberal art majors, adding up to 11 liberal art majors total. Same for business, same for technology, and they all add up to 30. See the structure? That's what contingency table is all about. Now, this is a main table, but there's going to be a bit of a variation here, and some of those variations will be discussed in section 4, but the majority of this will be discussed in the next chapter, or in next lesson, lesson 4. Now, please note that all these numbers are frequencies, just counting the number of people here. What if we change those into relative frequency by dividing everything by the total of 30? I can do that. Divide everything by 30. Basically, there are 6 female liberal art majors, so out of total 30, so 6/30. So that's 20%. And then there are 5 male liberal art majors out of total 30, so 5 divided by 30, about 17%. It's not precise, but some rounding, and so on and so forth. So we get contingency table for relative frequencies as well. And then here's the bar graphs associated to those relative frequencies. This box represents male liberal art majors, 17%, and this one represents female liberal art majors, 20%. And so on and so forth. There's 6 categories, add up to 100%, or pretty close to it, maybe not precisely because of some rounding here. Alright, there goes an example of cross-tabulation or contingency table. That's a good way to describe the bivariate data when the data is given by 2 qualitative variables. Alright, now let's go to the next example. A bivariate data set given by 1 qualitative and 1 quantitative variables. This is the least important of the bunch. Alright, here's a class, and this, by the way, is an actual class I had a number of years ago, but I withheld the name of the course, section number, a number of students, which year, pretty much everything except for scores, so it's okay. And then we have students 1 through 18, and then we have 2 variables here. One variable is obvious, scores. That's the quantitative part. What's the other variable here? What's the qualitative part? Those are the names, nominal variables. Exam 1, Exam 2, Homework 1, Homework 2, and projects. Those are categorical or nominal variables. So we have those 2 variables. Now, how do we use those descriptive statistics and then present it graphically? Well, there's no real good way, as a matter of fact. Usually the best way, or the best possible way, is just consider all those different categories, different names as completely separate variables, and then do the single variate descriptive statistics for each category and put those together. Here's an example. A side-by-side box whisker plot. Look at exam 1. Here's a data set, so we can find the 5-number summary of its own. Exam 2, we can get the 5-number summary of its own, and so on and so forth. And then put those together side by side. Here we have the side-by-side box whisker plots. And then we have side-by-side histograms. Now, in these descriptions, the key point, all these are associated to same student. Is it playing any role? No, it is not. You see? This entire thing and that entire thing were done separately and then put together. And same goes to all the other colors as well. So whether we are using bivariate data given by 1 qualitative and 1 quantitative variables, or just 5 completely separate quantitative variables, well, there's no difference here. And that's why I said this is the least important of the bunch. The cross-tabulation or contingency table, that's important. This one, not very much. Now, another important topic here. When we have 2 quantitative variables, we are going to get something called a scatter diagram. Let me show you. Here's a data set, actually the same data set, and let's create a bivariate data set associated to 2 quantitative variables. One way to do that is to get any 2 column, like these two, exam 1 and exam 2, and compare those two. Or homework 1 and homework 2 and compare those two. Or say exam 2 and projects. Or exam 1 and homework 2. Well, we can do various, but then again, what's the point? Let's consider only these two, exam 1 and exam 2. And then homework 1 and homework 2. So this one first, and then next, this one. Or these two and those two. That's how you do it. These things are called scatter diagrams. Here, each dot represents a student. Remember, bivariate data, we have two variables coming from the same elements. So this score, let's see, 54 from midterm exam and 95 from the final exam, they're both coming from the same student. So pair them up, 54 comma 95, where is it? X coordinate is 54, Y coordinate is 95, it's right here. Let's consider another student. How about this one? This student scored really high in the midterm exam, about 90, but the final exam, about 70, not very good. Well, where is that student? Student number 9, 89 and then 72. There are 18 students, so there are 18 dots. If you have something like 20 pairs, then you can easily produce this with traditional paper and pencil and ruler. If you have about 50 dots, okay, it's going to be a bit more time consuming, but you can do it. If you have 1,000, well, you can't do it. So you'll have to use technology, and we'll discuss the use of technology in separate video. Here, if you concentrate upon homework 1 and homework 2, you're going to get this, a scatter plot. Okay, we do have some time left, so let's talk about technology. I wasn't planning on it, but let's go ahead and do that. Okay, let's open up MS Excel here. Okay. All right, forget about these. Yeah, I'm not going to consider any of those. Okay, let's consider exam 1 and exam 2 together. So we're producing a chart. In that case, before selecting a cell, we have to select the data set first. So use your mouse to select these two, exam 1 and exam 2. Okay, and then go to Insert, select Charts. And recommended chart, okay, MS Excel is recommending the proper chart, the scatter plot. But let's assume it was not as smart and then suggested something else. In that case, you have to go to All Charts and then go to Scatter Chart here and then make your choice. If you have two different colors, that means two separate variables. No, that's not it. We want actually one data set. Bivariate, but it's one data set. So it's this one, single color. That's the one, and then here is the scatter plot. That's how you use technology. One more thing here. Go to plus here, and then you can even find the trend line, the line of best fit. We're going to talk a little bit more about this trend line or the regression line in section 3 of this notebook. Okay. So much for section 1, and we'll meet again in a separate video for section 2, 3, and 4.